Hi, welcome back to Science 1206, the Weather Dynamics Unit. I'm Miss Ledwell, and in this video, we'll talk about climate change. Let's get started. First up, let's look at the difference between the terms weather and climate. Weather describes the current conditions of the atmosphere in a particular place and at a specific time. Weather is what is reported on the news, television, or radio. Weather includes daily changes in precipitation, barometric pressure, temperature, and wind conditions for your area. Climate describes the patterns of weather conditions in a region over a long period of time, such as years, decades, centuries, or even longer. Now I'd like you to pause this video and watch the video "The Climate is Changing, but How's the Weather?" You'll find this video in Brightspace in the same area you found the instructional videos. This will help you learn more about weather and climate. Once you've watched that video, return here and resume this instructional video. See you soon. Now we'll look at the term climate change. Climate change refers to the change in typical weather patterns, including changes in temperature, precipitation like rain and snow, wind and storms within a specific area over an extended period of time. The Earth has seen periods of both warming and cooling throughout its history. Currently, the planet is undergoing a rapid warming phase. Since the 1800s, the average global temperature has risen by almost 1 degree Celsius, indicating a faster rate of increase now compared to Earth's past. The long-term increase in Earth's average temperature is called global warming. Let's look at the change in global temperatures using the simulation from NASA. On the side, it shows you that dark blue indicates a change of -2 degrees Celsius, and 0 is the light blue. A change of 1 degree Celsius is kind of a orangey color, and a change of 2 degrees Celsius is a reddish color. So right now it's showing 1880 to 1884. Now we're in the early 1900s. 1930s, 1960s, 1980s, and we're in the 2000s now. So it stops at 2018 to 2022, and we can see that there's a big difference in global temperatures, an increase in global temperatures since the 1800s. If we look at the key here, the red areas are experiencing a temperature difference of 2 degrees Celsius, and the kind of orangey yellow areas are experiencing a change of around 1 degree Celsius. Now let's look at a different simulation, also from NASA. In the center we have the year 1880, and then we have a change of -1 degree Celsius, 0 degrees Celsius, which means no change in temperature, and a change of +1 degrees Celsius. So you notice in the center that the years are going up. We're now into the 1900s. And we're in the zero, pretty much in the 0 range, so the temperature hasn't changed much. Now we're in the 1950s, and we're above the 0 degrees, so the temperature is changing. We're in the 1990s now, and now we're in the 2000s, and we can see a significant change in the temperature there in the 2000s. So change of 1 degree Celsius or even higher. At this point, they've changed the graph, so we have a different perspective. And you can see the 2 bars, 0 degree bars, means that there's no change in temperature. From 1880 up until the 1970s, there's not a whole lot of change in global temperatures. But once you get into the 2000s, you can see it branching out into a change of about 1 degree Celsius. The next thing we're going to talk about are carbon dioxide levels. Both natural phenomena, such as volcanic activity and solar output, and human activities, like deforestation and global carbon emissions, contribute to climate change. There is a notable link between atmospheric carbon dioxide levels and Earth's surface temperature changes. As carbon dioxide levels in the atmosphere rise, Earth's surface temperature increases. Conversely, when these levels drop, the temperature decreases. The correlation between carbon dioxide concentrations and Earth's temperature is critical in understanding climate change. Here we have a graph from the National Oceanic and Atmospheric Administration of atmospheric carbon dioxide levels collected at an observatory in Hawaii. It starts in the 1960s and goes up to just past 2010. What do you notice about atmospheric carbon dioxide levels over this period of time? You're right, you notice an increase in atmospheric carbon dioxide levels. And remember that as atmospheric carbon dioxide levels increase, Earth's surface temperature also increases. My second question for you to think about is, why are atmospheric carbon dioxide levels increasing? Here's another graph of carbon dioxide levels. And you can see it says for millennia, atmospheric carbon dioxide had never been above this line. But look at where atmospheric carbon dioxide levels are today. So today, atmospheric carbon dioxide levels are way beyond what they've been in the past. Why do you think that is? And how is that contributing to climate change? Well, this graphic from NASA says carbon dioxide traps heat like a puffy coat. It tells us that humans have increased the amount of carbon dioxide in our atmosphere by 50% since 1750. So why have the carbon dioxide levels been increasing? It's because of human activities, things like burning fossil fuels. And the effect of these carbon dioxide levels? We've made Earth's insulating puffy coat thicker than it's been in millions of years, and as a result, our climate is warming rapidly. Now it's time to continue to the next video. Before you do, take a 30-second break, stand up and stretch, and then continue on to the next video.